So in this video I'm going to integrate square root of x squared plus 9 with regards to x. Now this is the second video on this same integral, and the first time we integrated it we used tangent as our substitution. This time I'm going to use the hyperbolic substitution. So this is our second version of this same integral. So as I've got x squared plus 9, I'm going to let my x equal 3 times sinh of theta. So let x equal 3 sinh theta. So that's what my substitution is going to be. So now my x squared, which is what I've got here, that's going to give me 9 sinh squared theta. Okay, now because I'm substituting, I need to take my derivative of my x. So my dx will be 3 cos theta. So with that information, I'm ready to just integrate in there with regards to theta. So change my variable from x to theta. So now I've got the integral square root of x squared, which is 9 sinh squared theta plus 9. And then my dx is 3 times cos theta. And then that's d theta. Okay, so these are multiplied. Okay, right. Now I need to do something with this. So I've got 9 and a 9. So I could take the square root of 9 out of it. So let's do that. So now I've got square root of 9 to come out, which is 3. And then I'm left inside with sinh squared theta plus 1. So that will be the same value. And I've got 3 cos theta d theta. So this time I'm going to put my 3 out the front and write my cos theta with d theta. Okay, sinh squared theta plus 1. Now there's an identity for that. So sinh squared theta plus 1. That's just the same as cos squared theta. So that's a hyperbolic trig identity there. So I can substitute that for that. And this 3 here I can bring out the front. So 9 times the integral of the square root of cos squared theta times cos theta d theta. Okay, so now this cos squared theta square root of, I can just cancel the square root and the squared out, and then cos theta times cos theta will just give me the integral of cos squared theta. So now I'm left with 9 times the integral of cos squared theta d theta. So in terms of theta, that's where this has got to for now. Okay, now cos squared theta, there's a couple of ways I can integrate this, but the way I would like to do is to use the power reduction formula for cos. So power reduction formula for cos n theta, and then that's d theta. Okay, so the power reduction formula for that, that's going to give me cos to the n minus 1 theta, and then multiply that by sinh of theta divided by n, and then I add on another integral with a constant multiple. So I've got n minus 1 over n, and then in here I've got cos to the n minus 2 and d theta, and that's also theta. Okay, now for this integral here, this would all have to be multiplied by 9. So my power reduction formula would all be multiplied by 9 as a constant multiple, and my n here will be 2. So for this I would have n equals 2. So all I need to do now is plug in my power reduction formula for this integral. So power reduction formula for n equals 2. I've now got 9 times this, so n equals 2. I've just got cos theta sinh theta. So I've got 9 times cos theta sinh theta, and n is 2, so I need to divide by 2. So my constant multiple can be 9 over 2. Okay, and then here I've got n minus 1 over n. So that could be 1 over 2, and not forgetting my constant multiple. So now I've got 9 over 2. Cosh to the n minus 2 theta. Well, if n is 2, I've got cosh to the 0, so that's going to leave me with 1. So then I've got my integral of 1 d theta. Okay, right. So I can integrate this, that's just theta. So let's just do that. So now I've got 9 over 2 cosh theta sinh theta plus 9 over 2, and that's just theta. Okay, now that's in terms of theta, so that's not going to be my final answer. I need to get it in terms of x. So what can we do here? Well, I've got sinh theta equals x over 3. So let's write that down there. So sinh of theta equals x over 3. So if I take the inverse sinh on both sides, I'll be left with theta equals inverse sinh of x over 3. So I can put that into my result so far and see where that takes me. So now I've got 9 over 2 cosh theta. Well, that's going to be cosh of this inverse sinh. So I'm going to just write that as that. So cosh of the inverse sinh function, which is x over 3 for this integral here. So that will go in there. So that is the same as that. So just that is that. And then my sinh of theta, that's just x over 3. So this is all multiplied by x over 3. So 9x over 2 times 3. So now all of this is included in this. And now here I've got 9 over 2 theta. Well, theta is the inverse sinh x over 3. So now I've got to add on 9 inverse sinh of x over 3, all divided by 2. So I'm just going to leave that constant multiple there as 9 over 2. Okay, right. So got stuff I can do with this one, and then I've got a trig identity I can use for all of this, and then this I can simplify off. So I'm going to bring this up to the top and continue with that. Okay, so now I've got it all up to the top here, and now I need to apply some trig identities that we can scramble with here. So 9x over 6, I know we can simplify that, but I just wanted to see how we got to that point there. So cosh of the inverse sinh function. So this one here, so cosh of the inverse sinh function of x over 3. Now if you do the algebra on that, you'll get that to the square root of x squared over 9 plus 1, which we can simplify even more. So basically this one, so that equals, so we've got this 1/9 here, so the square root of that is 1/3. So if we take that out, 1/3 of the square root, so that will take care of this x squared over 9. So I could just write that as x squared rather than having a fraction in my radical. And now to get the equivalent version of this, I now need to put a plus 9 in there. So if I multiply plus 9 by the square root of 1/3 squared, I'm going to get 1. So that will give me that. So that's what I can plug in for this. So now I've got 9x over 6 times 1/3 of the square root of x squared plus 9. So that takes care of all of that. Now this one here, the arc sinh function of x over 3, what we know is here, if we transfer that into logarithm rather than have it in hyperbolic, we know that sinh of x, that equals the natural log of x plus the square root of x squared plus 1. So that's the logarithmic identity for the inverse sinh function. So now if you've got x over 3, so of x over 3, that will give us the natural logarithm of x over 3 plus square root of x squared over 9 plus 1. And then, well, we did before with this one, we can take 1/3 out and leave us with x squared plus 9 inside there. So that's what I'm going to do now. So I've got plus 9 over 2, natural log, and then x over 3 plus, so now I'm going to have 1/3 square root of x squared plus 9. Okay, so now I've got all my trig functions taken out. I'm now back into x, which is what my original integral looked like. So now I need to just try and simplify this off and see if I can come to some sort of conclusion. So now I'll have 9x times 1 divided by 6 3s are 18. So now I've got x over 2. And then on top, multiply with that, I've got square root x squared plus 9. So that becomes that. So now I've got 9 over 2 times my natural log. And then here, both terms are multiplied by 1/3. So I can have 1/3 of x plus square root of x squared plus 9. Okay, and that can go in the absolute value. So now I'm just going to simplify this off with just some nice fractions here. So I can take out x times square root of x squared plus 9. That's all divided by 2. And then this one here, I've got plus 9 times the natural log, absolute value of 1/3 x plus the square root of x squared plus 9. And then all of this will also be divided by 2. So that will be dividing all that. And then all I do now is add on to that my plus c and not forget to put my absolute value in there. So now I've got plus c. So that takes care of that. That's not included in the fraction. So I'll just make sure that's clear. And now that is my answer with hyperbolic trig substitution. Okay.